Hello and assalamu alaikum everyone. I'm Osama Aslam. So today we are going to discuss about non-linear dynamic analysis, time history analysis, and non-linear static pushover analysis. So let's open etabs. I will design a four-story building according to the building code of Pakistan because Pakistani mostly follow the American codes. And etabs also doesn't have the Pakistani code available in it, but we can input response spectrum of Pakistani code in that, and then we can compare the results. Recently I made a designed a building according to the Chinese code. So what will our dimensions in the extraction? The spacing is 5.5 meter at there are 4 grids, and in the y direction there are also 4 grids at 6 meter. Story height is 3.2 meter. So let's make a new model. Built-in setting metric SI unit for meter and US customary for feet. So for United States it is already selected, the latest one. Concrete and steel. Grids of our grids are 4 4. The spacing is in our x direction is 5.5. In y direction it is 6 meter, and number of stories 4. The story height is 3.2 meter and also 3.2 meter. You can change also the grids here, and also you can name it here, rename it roof or whatever you want. So that's all. Okay, this is an okay, so this is an etab checklist for structural design. First of all, we have to check our architectural drawings, and then we mention grid dimensions, story data, units, and then save the file. Okay, let's save the file. We can save it anywhere. Okay, 4 stories, sample. Okay, 4 sample. So this is saved. Let's check what is step 2. Define the material. We have to define concrete and steel that are we going to use. So material properties. For the material properties I am using concrete of 3000 psi, and the steel bar is 345 or 400 fc, and this is because I use this in China, so I must use same strength and in Pakistani code also. So add a new material, concrete 3000 psi. Okay, I can name it C30. So here you can modify it to, for example, you want to change the strength because we are using 3000, so we can increase it to 30 megapascal. Here you can check the stress strain plot for the concrete, and these are 3 parameters, very important: immediate occupancy, life safety, and collapse prevention. These are actually even there are plastic hinges in the structure. Plastic hinges, actually you also know that where there are more chances of loads, and there are more deflection as compared to other points. Okay, so no need to change anything here. And then rebar grade 40, 400 or 40. Here you the density, this is density 78, this one, and the maximum strength minimum strength must be 413. This is also the stress strain plot for the rebar, and these are the three levels. Okay, the material is defined. Now we need to define the sections. This is the defined reinforcement bar size. This is you can do whenever you, after the analysis, you will design in etabs. So currently you don't need it. Section properties, we will first of all delete these, because if you keep it all, it will be too tough to identify your required section. So add a new property, rectangular concrete. For example, for I am taking initial sections, these you can take any. If this pass, then you no need to change it, but if they don't pass, then you need to increase your section, beam size and column slab. I'm taking beam as 250 by 550 and column 550 by 550, slab 150. These are my initial sections. So beam is 250 by 550. So 550 by 250, and the modifiers for beam is 0.35. Rebar, here you have to select M3. Actually this is M2 and M2 the moment about major axis, M3 is movement about minor axis. Here you will change grade 40. Spacing is actually depend upon each code. For the column we keep for 40 millimeter, for the beam we keep 25. So you have to check your own code. Here we also change that C30. So this is and this here you can check the section properties. So okay, then you can delete this. Then we have to define a column, same concrete rectangular. Column was 550 by 550. Here you will change C30, 550 by 550. For the column, the modifier is 0.7, and for here don't need to change anything. Currently we can do it when we will do the design. Okay, so we already defined material. Now we can draw our beam, column and slab. For the column, first of all we will draw columns. Here select all stories. Here if you draw here, it will automatically go on all stories, so you can simply do like this. So you can see all are defined. Now we can draw beams. Okay, beams is also already defined. Then you can draw slab. Okay, we didn't define the slab yet. Define section properties, slab sections, delete properties, add new property, slab 150, 3000 psi. Here you will modify. For slab it is 0.25. Okay, here 156 inch, and yes, okay, we can delete this one. Okay, now go to slab here. here we have to slab 150. So slab is for concrete and deck is for steel. So okay, all stories. Okay, so now go select one story, go to basement, select this, oh sorry, select this and delete it. Then you can select all the bases and make it restraint. Okay, fixed, apply, okay, save it. So let's check, we already defined the section materials and also assigned. Then we can okay, diaphragms. Okay, we can, then we can, there are two ways to define diaphragm. First of all, let me tell you actually what is there are three types of diaphragm: rigid, semi-rigid and flexible. For the rigid, there will be no motion, it will be totally stiff, and for the semi-rigid, it will be stiff with some deformation, and flexible, it is mostly used for thermal analysis and thin slabs. So in our case it will be rigid. Okay, let's check the diaphragms. It is already defined rigid, so no need to change. So select all. First of all, change all stories, select all, now everything is selected, assign, shell, diaphragms, D1, apply. So you can check here the diaphragm is assigned. So now the diaphragm is already assigned. Now you will do, yeah, it's for the snap option. You can check if something is not like you can't see the midpoint or anything you can't see, so you can change the setting in the snap option. And the next step is draw the structure. We already draw a structure. Yeah, now this is the main difference: response spectrum and time history analysis. So for the response spectrum, yeah, functions, response spectrum. If your code is available in the etabs, then you can directly define from etabs. But if you like Pakistani code is not available here, so then you have to go to from file and add new function, and then browse, and you have to check where is our response. For my case, I already uploaded my video that how to get response spectrum for any code by Seismo signal or Seismo match or Seismo, and also how this is a very important thing, because okay, I will tell you later about this. First of all, let's import our Pakistani response spectrum, and for Pakistani response spectrum, you have to like tell which I'm selecting which area. All files, I am selecting Pakistan Islamabad. So this you can see they already showed here. We can name it Pakistan, okay, anything. Okay, so you can delete this, and okay, the response spectrum is defined. Then you can define time history loads from user, add new function. Here the point is that here from file, here the point is that while importing the data into like time history, especially in etabs, you have to model your scale your all of the data to scale 1, so that you don't have to change any factors. So for example, I will import 4 quick data here, so I will upload here the scaled one, that all scale to 1. And that this video is related to this, how we can scale our PGA values to scale to 1, so that it's easy for us to calculate the scale factor. So okay, browse earthquake. Okay, so for example, I take this one, and you can I will, so because 0 here, you have to check your format. For example, here in this there are no like 0 lines to skip, so it is starting from the line 1, so here will be 0 lines to skip. You can provide 5, and also you can provide here, you can go more. So this is the display of our data. Okay, this is defined, you can delete this one, and then again new function, you can define any I will define 2 4. Here are also two things. People will ask that how which direction, because there are 3 directions: UX, UI, UZ. So what I did, I am importing the maximum value in any direction. So you have to already define one maximum value, either it is in UX or UI. So I already decided what is the maximum value, so that is actually best solution. So if you don't want to do it, you can also put both values, UX and UI, and then you can also do that analysis. 0.05, here you can 5. So the name is automatically changed when we can define 4. Okay, one more. Any you can do. So our earthquake data is input. Already we input the now. Yes, now we can define our mass source. This is also very important, that for example, now mass source Seismic Pakistan. Here I will select this 2, and I will do live 0.5. This is actually different, this depends upon you how you can do anything. For example, I show you what I did in my previous seismic channel. I selected actually self mass, additional mass. First of all, select your 3. If you don't select this, then you have to, if you don't select element stiffness, if you don't check this one, then you also have to add dead load here 1. But because I already selected here the check here, then you don't need to add separately dead mass. I mean here, because if I uncheck this, then I have to I also have to add dead load here, this one, dead load 1 as a 1. But because I already added check this one, so no need to add here. So yeah, that's all. Some people take it, if your load, the concept of mass source is that if your load is dead load and live load is more than 3.5 or something, then the reduction factor will be, addition factor will be 0.25, but it is less than 0.5. so this is a different concept. So you can see this is a mass source, and then what is the next step? response spectrum, and then load patterns. Yeah, let's check the load patterns. Function, mass source, speed at of load pattern. Dead load, dead and live. Then you can add super dead. Here you will select super dead, add new load, and then you can earthquake X, seismic. Here you will select because we don't have Pakistani, so you can select any here, and it's earthquake Y, seismic. Yes, add new load. And no need to add, because we will do the time history, so no need to add wind load. Wind load is useless, but you can add if you want, but it doesn't make any difference. So here you have to, for the Y direction, you have to uncheck all of this and check this one, eccentricity 0.05. okay, and here you will see, for example, I am using Islamabad, so I have to see what are the values for my Islamabad code. So let me check in my, not here. You have to see the SS value and S1 value for Islamabad. Let me check. Yeah, this one. The SS value is 1.302 and S1 is 0.381. 0.381, 1.302. Side class B, okay. SD, my from SD, and this will automatically, this is 5 for my case, and other thing is, yeah, that's all. Here base and story 4, okay, and similarly here you can modify 1.302, 381, ST5. okay, so these are the load patterns. Save it, save your model, and then what is the next step? Assign the loads. Okay, let's assign the loads. Select slabs. We just define the load to slab. It will automatically transfer to beams and columns. So for the shell loads, we go to, for that we define two types of load, dead and light. So uniform dead, we define 2 point, let me confirm, the dead load, yeah, 3 kilonewton in excluding cell weight on all other stories, but on the roof, and the dead load will be 0.25 and other will be 2.5. okay, so 3 kilonewton. Gravity, okay, let me check. Yeah, dead load is 3 and live load is 0.75. okay, got it. Apply, okay. So select here one story. This is already roof, so here we will again, it will be assign shell loads, uniform, live, 0.75, apply, or okay, maybe we can do like this. First we define on all, assign shell loads uniform live. First we define 2.5 on all stories, and then here we can just apply on the roof separately, assign shell loads uniform 0.75. so this is only for the roof. Okay, we already defined the loads. Then okay, load cases, this is also important step. Define load cases. So these are already defined by the model. For them we can modify this. Here we select reads analysis, and yes, mass source, add, we select here acceleration, UX and UI. Here because UX, our stories are 4, so because we have 4 stories, so 4 stories mean if it is already written 3, because it will also consider UX, UI. So here will be 8, 4 to the 8, and yeah, this is for the like reads analysis. Let me confirm this thing from my notes. Yes, that's okay. No need to change anything here. Okay, and then add new case. Here we will select non-nil time history analysis, yes, non-final element analysis, add acceleration, because we will select add only one acceleration, u1. I told you that you can also add u1 and u2, but because I already take the maximum value in one direction, so no need to change that thing. So here the thing is that what we have to do, for example, I have to check that which load case I added. For example, here for example, here I was here, sorry, time history, finite, add acceleration u1. Here I have to first of all Christchurch, New Zealand, we added 4. So how to select this I already explained in this video that how we can scale our response spectrum. So it is actually in 90, it will be 1962 981, because our PGA required PGA 0.2 and G value is 9812. so if we multiply by this 98102 by 0.2, 9810 multiplied by 0.2, we get 1962, and we already scaled all our earthquake to scale 1, so the scale factor will not change. So here now for everything what will be changed, actually I show you what will be changed. We will see that I will open Christchurch and here number of total points 2400. Here it will be 2400 and the time is 0.02 and no need to change anything else. Okay, then again second earthquake, or you can just copy of this case. Okay, just change the here earthquake Turkey one. This will not change, and I will open the Turkey. Here it will change 13,751. And the 0.004. Yes, no need to change anything else, and you can change you can change the name also. DU, let's see, it was Christchurch. And then again copy of this case, change here to Morgan Hill, and open the Morgan Hill. $5,999 and 0.05. Alright, yes, okay, again copy of this case, the last one, Northridge, and open the Northridge here, 4,001. Okay, so this is the way of adding time history. And then if I want to add the pushover analysis, what I will do, add new case and non-linear static. Okay, here Seismic Park. For it is actually the two cases. First of all, we will add for the zero initial condition, we will add load type here. Load pattern is here, scale factor is this one, that load, and it doesn't matter, it is okay. For this one we select P delta for the load type, P delta full load, and this is for the initial design. We can say load, we can say dead load plus 0.5 live load, and here we will add again, here we will change live and 0.5. this is for, then again add new case, non-linear static pushover, continue for now. For this is from here for the displacement acceleration, UI, or you can just add one, that's also okay, minus scale factor will be -1 because we just need one. So displacement control, here actually we provide 6 inches, or it is automatically calculated. Story 4, yes, and we can check multiple states, and for the multiple states we can increase our, for example, minimum 100, maximum 500. Okay, and this doesn't need to change. Here we select large displacement, P delta large. Okay, So this is the way to define the static pushover, non-linear static pushover, non-linear time history. So this was very important. Save this model, and this is also done. Load cases, assign the loads, then load combinations. Okay, now let's define load combinations. Load cases are done, we already done. Load combinations, add default, concrete frame design, converter user defined. Okay, so yes, everything is done. Yes, everything is done for us design. Now we have to check our model. Okay, model has been checked, no warning messages are okay. So now you can see that everything is defined, like material sections, diagram, mass source, time history analysis, and pushover, load pattern, load cases, load combinations. So next thing, we already checked also the model. Now we have to set load cases to run. I will suggest you to do that. For example, first of all, you just run the analysis with the simple 3 cases, this 5 cases, and then you can design your building, and then if the design is passed, then you can run first of all time history and then push over. Okay, first of all only run the first one, dead live model, super dead, earthquake, because these are all first 7 loaded are included in the different combinations, load combinations. Okay, so run now. It will take some time. So the analysis is complete. Multi-step linear static analysis. The no error came, so then we can check deform shape. Okay, I will show you later. Then we can design. First of all, design, because we can see this all design combination are already here, so we just start design check, and yeah, you can see here all are in permissible limit. So what is the criteria to check? I can go into elevation here. So what is the formula actually to calculate the number of bars, how many number of bars we need to provide? We need to increase the beam size, because here you can see that overstressed, beams are overstressed. Yes, our beam was 250 by 300. We first of all we can go up and then 300 by 600, and then also the column are okay almost. So I was telling you how to calculate. Then for example, we have to check here the maximum area for the longitudinal reinforcement. It is already 3025. So there are different bar sizes. Let me show you. For example, yeah, these are Chinese bar size and this is Pakistani. We are doing Pakistani. So for example, for 16 it is 201, 20 is 314. So I will divide the 3025 divided by the area of bar, and I will get then for example which bar I want to use 16, then I will divide by this area, and if I want to get the use 20 bars I will divide this. And so for the column we have to do, like for example I am getting 10 bars, so I have to decide how I will provide. For example I will 1 2 3 4 10, total 12 bars. For example 5 6 7 8 9 10 11 12. This is how I will provide. And for the stirrups, maybe number 8 and number 10 I can decide, and like this. For the beam we can also do the same thing. And for the beam, because all our beam did not initial section, so we have to increase the sizes. Okay, so unlock the model and go to section properties, modify. We can do the 300 400 by 800, 800 by 400, or maybe 400 by 800. This might be more good. And rebars are okay. Again run analysis, or assign the beams, select object type beams, select or just do like this. Yeah, we already changed it, so no need to. So again analyze. Okay, run now. Analysis is complete. Design, start design check. Now you can see all the beams are okay, they are black and in the permissible limit. So now I can run the time history analysis. First run. It will take maybe some time, a little bit longer than simple analysis. There might be some warning messages, so the warning message is okay, but analysis is complete. You can see analysis is complete. It's very fast because my computer is very good. So time is T. Then I can run the pushover. Pushover analysis being run. Okay, this is also complete. Now I will show you how I can check some different results. Here you can check the deformed shapes, and here you can check the story response plot. Yeah, this is earthquake X, earthquake Y. That model you can check the different step, because it is zero time. This is the maximum minimum. You can check different all the time, like story stiffness, displacement, diaphragm, draft brief. So you can check different things here. Then you can also check combined story plots, and in X direction this is in Y, this is Christchurch. Okay, this is, and you can also animate it. Okay, you can see here it will move, and here you can also take to the Excel file, formatted and unformatted story data, and you can take to the Excel. Here you can export table, and then you can story respond, and you can take to the Excel and make your changing accordingly. Here is the response spectrum curves for different earthquakes, and this is the static pushover curve. And there are two types of the FEMA 440 EL and American Society of Civil Engineers. Two types of you can get pushover. Yeah, we can select according to our need, and then energy also, and you can also check the the forces diagram. Then you can also check the moment. You can here start animation, and that's all. And if you need any other information, you can ask. And here you can check the different detailing, steel, concrete detailing. And I will tell you some concepts that are very important. Yeah, these are three. First of intermittent occupancy, then life safety and collapse prevention. Story drift is actually the limit of acceptance criteria, 0.5% service level. This is actually service level, but for MC level it is different. Yeah, these are some basic equilibrium equations. We can also perform the IDA curves to get fragility curves. This is a Mender model being used in the etabs. Okay, that's all.